We're going to learn about transformations on this video. I'm going to go over different things. The first one is, what is a rotation? A transformation that turns a figure about a fixed point. The number of degrees a figure rotates is the angle of rotation. Sketch and label your quadrants with Roman numerals and their signs. So go ahead and write this, draw this next in that small space. You can do it small. And then write, do X and Y axis, quadrant 1, 2, 3, 4, and positive, positive for X and Y, negative, positive, negative, negative, positive, negative. Please write this down. If the angle of rotation is positive degree measure, you are rotating counterclockwise. For example, 90, 180, 270, and 360. So one turn is 90, two turns is 180, three turns 270, four turns is 360. If the angle is rotation is negative degree measure, you rotate clockwise. Example, negative 90, negative 180, negative 270, negative 360. So negative is clockwise, positive is counterclockwise. So rotation notation example is a 90 counterclockwise rotation about the origin would be given as, you're going to write O for origin. R means, capital R means rotate. So rotate at origin at 90. This means rotate your figure at origin at 90 degree, counterclockwise because it's positive. If you get RO negative 90, if you see this, that means rotate at origin clockwise because negative is clockwise. So practice, give the notation for each of the following. Rotation at point Q, write Q, so point you write it here. Clockwise, negative 180. Rotation at point S, this is the point where you put 270, that's counterclockwise. Rotation, origin, 360, counterclockwise, because counterclock is positive. Rotation at origin, 180, counterclockwise, that's positive also. Equivalent rotations. State a rotation that will be equivalent to the rotation given. There are 360 in a full rotation, right? So what you need to do is, you have rotation at origin at 260. If I turn 20 degrees, if I go counterclockwise, if I do negative 340, that means it's going to be same position if I go clockwise. So basically you do 360 minus 20 and to go backwards. If this is positive, you make it negative. Here 360 minus 10. If this is negative, make that positive. Because when I go counterclockwise, 350, it's going to be same position as clockwise, negative 10. So you just do 360 minus the number. If this is positive, you put the negative. If this is negative, you put the positive. So 360 minus 301 is negative 59. So these two, the shape will be on the same position. 360 minus 30 was 330. But if it's negative, you put the positive. 360 minus 56 is 304. But if this is positive, put the negative. 360 minus 145 is 215. If this is negative, that's positive. So this is all at the origin. So you simply subtract and put the opposite sign, and they're going to be, when you rotate each of them, the shape will be on the same spot. Because one is going counterclockwise, one is going clockwise. So an easy way to do rotation in the coordinate plane, write down the order pairs for all your vertices. If you're rotating 90 and negative 90, 270 or negative 270, switch the X and Y in which of your order pairs. So if you have 2, 1, you write 1, 2. If you're rotating 180 or negative 180, leave the order pair as they are. Determine which quadrant your image will end up in and match the signs of your new order pairs to the signs of that quadrant. Plot your new order pairs. So basically, you're going to look at ABC, label it, write the points 2, 1, 2, 4, 4, 4. And then if you go to negative 90, it's going to go one turn clockwise. Clockwise this way. So your shape is going to be here. And it's going to be X is positive, Y is negative. You can see that. So all your XY points will be positive and negative. So you're going to switch. If it's 90, right here it says, if it's 90 or 270, you're going to switch X and Y. So you're going to switch. Instead of 2, 1, you're going to write 1, negative 1, 2. Instead of 2, 4, 4, 2, 4, 4, 4, 4. And then all your X will be positive because it's going to be in this quadrant 3. Quadrant 4, and then all the Y's are going to be negative. So just put positive and negative. So this is going to be your A, B, C. You put those 3 points and connect and make a triangle. Go ahead and do this part, please. So basically 90 is switch X and Y, and then look where it's going to be ending up. If it's negative, clockwise, positive, counterclockwise, and you decide which quadrant it's going to be. Look at the signs on the quadrant and put those signs for X and Y. So this is not on your paper. This is just on the screen because I wanted to save the spot. So you please look at this. This one is not on your paper, so you just have to look. So here I have this triangle. I wrote the points A, B, C, 2, 1, 2, 4, and 4, 4. I want 180. So 180, you write the same points. 2, 1, 2, 4, 4, 4. But you just have to know where it's going. So this is positive, so it's counterclockwise. So you got to go here, here. So 90 is 1 turn, 180 is 2 turns. So from here, 1, 2. And then this quadrant is quadrant 3. X is negative, Y is negative. So it's going to be negative, negative. So write the same points, 180 same points, and just put negative, negative for X and Y. So this is your new points. So you're going to draw, put these 3 points and draw, make a triangle. That's how you do the rotation. I'm going to show you this one. This one is negative 180, so it's clockwise. And look here, the points are actually on both. This triangle is lying both on quadrant 2 and quadrant 3. So in this case, you just do point by point. So what I'm saying is, B is negative 4, 1. X is negative 3, negative 2. N is negative 5, negative 4. You're going to write those points first. And then 180, you just write the same thing. But you need to understand 180 is 2 turn. So do each point turn. So what I'm saying is take this B, go 1, 2. So the B is going to be on quadrant 4 right here. So that one is going to be positive X, negative 1. So write the same thing, but make this X positive, make this one negative. Now look at this N. Instead of quadrant 2, it's on quadrant 3. So take this N, go 1, 2. So it's 2 turns. So this N is actually on this quadrant 1. So you're going to write the same digits, X and Y, but this quadrant is positive, positive. So you're going to write positive 3 and positive 2. And then you get the X one. This is on quadrant 3. Go 1, 2. You're going to go 2 turns. So 2 turns means go each 2 quadrants over. So that's X. The quadrant is on positive, positive. That's why this one is positive, positive. So these 2 points are on quadrant 1, but B is actually on quadrant 4 because where it's located. So when you see that, you're going to do each point and turn each point separately, clockwise twice, okay? When something is rotated 360, it's the same position, full circle. So you're going to do this one on your own, and you're going to write your answers. New 3 points for rotation, 270. So 270 is 3 turns. So I'm going to ask you to do that on the app puzzle and write the points. Next, we're going to do translation. A transformation that maps all points of a figure the same distance in the same direction. In other words, a transformation that slides a figure without changing its size or orientation. The image looks identical to the pre-image, and it is just in a different spot. So translation notation is you move figure, let's say 2 to the right, 3 down. It will be given as, you're going to get X and Y. To the right, you add 2. Down is Y minus 3. So at left and right is X, up and down is Y. So if you actually get you're going to start with t, and then xy, and then 4 right will be x plus 4, y minus 2 for the down. 9 left will be just start with this, x minus 9, 1 up, y plus 1. And then I want you to do these two and check it. So what you're going to do is you're going to translate right here. T means translation. Translate x and y. So we're going to slide. So you're going to do x plus 5, y minus 1. So from here you just do 1, 2, 3, 4, 5. And then go 1 down. So that means from here to here, go 5 to the right, and then go down 1 and put a new point. So you just do that for each point. You have MATH, just put apostrophe, that means new shape, has apostrophe next to each one. So please do that on your paper. Just go 5 to the right, 1 down. Always do X and then the Y. So let's look here. This is the original shape. This is the new shape because it has apostrophe next to each letter. So always do X 2 to the right and then 5 down. That's what they did. So do B to B and see it. And then C to C, 2 to the right and then 5 down. So the rule is X plus 2, Y minus 5. So that's the rule for these two translation. So pre-image are these, image are these. That means pre-image is the original, image is the new one because it has apostrophe next to each letter. What's the rule? So from 3 to negative 3, you do minus 6. 6 minus 6 is 0. A minus 6 is 2. 5 minus 6 is negative 1. Look for that. And then you just do minus 6 for x. And then look at from 5 to 1, 6 to 1, 3 to negative 1, 2 to negative 2. Look at the y's. It's y minus 4. So please write this. Translation, xy, this, x minus 6, x minus 4. So let's look at dilation. Dilation means a transformation that changes size. So dilation means the shape itself does not change, but the scale factor is used to make the figure larger or smaller. So same shape, but different size. So the image of dilation is always similar to the pre-image. A dilation with scale factor greater than 1 is called enlargement. A dilation with a scale factor between 0 and 1 is called reduction. So right here, the scale factor is 2. So everything's double. Look at here, each side is double. If this is 2, this is 4. So you multiply by 2. Reduction means this is the original. This is the, so this is the pre-image. Pre means before. This is the image. Has apostrophe next to it. That's the later one. Then it's 1/4. So this is 8. The 8 divided by 4 is 2. That works for every single side. So a dilation center at the origin with a scale factor of 3 will be given as this. So when you see D, that means dilation. O is the origin. 3 means that the scale factor is 3. So that's 3 times bigger. Write the notation for each of the following dilation center at the origin. So if the scale factor is half, that means it's going to get reduced. So you're going to write D, 0, which is for origin, or O, comma, half. That's the scale factor. If the scale factor is 5, you're going to write D, origin, comma, 5. Which of all is the enlargement? Which one is reduction? This one is enlargement because it's 5 times bigger. Reduction is this one. That means half the size. So do the lines like this, please. So write the order pairs of the pre-image, then perform each of the dilation. So here you have ABC. Please write these points for ABC. And then we're going to do the dilation 3 times bigger. So just write ABC and multiply each point by 3. Negative 2 times 3 is negative 6. 1 times 3 is 3. So each number is multiplied by 3. This is your new points. So draw those 3 points. That's in green. So it's 3 from the original pre-image. The image is 3 times bigger, this green one. So what I want you to do is write these points. The point of the pre-image is all the same. The scale factor is 2, so just multiply each point by 2. Write the new points and then draw them for me on the paper. If the scale factor is half, that means it's reduced by half, then you just write the same points, pre-image, each multiplied by half, and then you can write them as integers. and draw right here.